I want to evaluate this improper integral. It's going from 6 to infinity. It doesn't matter where I'm starting. It's an integral that's defined on this entire interval, and it goes out to infinity in the bound. Also notice that this integral, this function that I'm supposed to integrate, I don't actually know if that's, I don't know how to find that antiderivative. So I'm not going to be able to give an exact answer if this converges to something finite. I just want to know if this is finite or not. So I'm trying to answer this question. So what I want to think of is a function that behaves sort of like this, that I can actually integrate and test fairly simply. So what's giving me a hard time is the square root of x. If I just take the square root of x away and just look at 1 over e to the x, I want to think about what happens, because basically I'm wanting to know, do I expect this to be finite or do I expect it to be infinite? Depending on what I expect, I may choose the function that I integrate differently. So what I think is that e to the x grows super fast. So if I was to integrate 1 over e to the x, that should converge, because this whole fraction should shrink down to 0 fast. So I have to think about the square root of x. I know the graph of square root of x looks like this. I'm starting at x equals 6, something like that. So if I do e to the x times the y value on here, that y value is going to be bigger than 1, and it's getting bigger and bigger. So this denominator is actually larger than just e to the x, which means this whole function is smaller than 1 over e to the x. So the first thing I'm going to do is note that this thing is smaller than 1 over e to the x. On that interval, on the entire interval. I believe that this converges, and so that tells me that I believe this will converge. So I'm just going to test this. If I integrate this from 6 to infinity, I want to make sure that I really do get something finite. If I do, then because of this fact, I can just use the comparison theorem to say that this integral is also finite, that it converges. So let's look at that integral. I'm going to have to take a limit. So I'm going to integrate from 6 to some general finite value t. And then I'll take the limit as t goes out to infinity. And I'm going to think of 1 over e to the x as e to the negative x, because I can find that antiderivative quickly. The antiderivative here is negative e to the negative x. So I'm going to think of this as negative 1 over e to the x. Then when I plug in my bounds, I get negative 1 over e to the t minus negative, so plus 1 over e to the 6. Remember, I'm just trying to figure out if this is finite or not. This 1 over e to the 6 won't play a role as t goes to infinity. So I'm just thinking about what happens to this 1 over e to the t. As t goes to infinity, e to the t also goes to infinity. And as that denominator is getting bigger and bigger, it's making the whole fraction shrink down to something extremely tiny. There's no, well, it just keeps shrinking closer and closer to 0. So this limit is 0 of this part. So the entire limit is just 1 over e to the 6. What I really care about is that that's finite. And now I can say since I know this, and I know that this function is smaller than that one, and by the way, this is positive, it's bigger than 0, and by the comparison theorem, this must also converge. I'm just going to say the integral. So, by the comparison theorem, the integral converges.